So what we're going to look at in this lesson are sectors. If we take a look at this here, so what we have is a circle. Now what we can think about, let's say if we want to break up a circle into sections, we can think about it as in degrees. So for example, the whole circle, the entire circle will be 360 degrees. So that would equal the whole circle. Now if I was to take, let's say I was to break it up into 4 quadrants, just like this, and if we look at each of these sections, and if we look at the angle that's here, so this angle is going to be 90 degrees. So that would be 90 degrees. So we can think about, if I was to take this whole section out, I would take out 90 degrees of the entire circle. That's one way that we can think about, like breaking up a circle into different, what are known as sectors. So if I was to take this piece out, so we would have something that would look roughly like this. So let me just change the color here. So we'd have something that would look roughly like this. Okay, so this here is what's known as a sector. And as we were saying, we have this angle here. And we use a symbol to represent the angle, which is known as theta. So it's just like a 0 with a dash through it. Okay, and all that represents is just whatever the angle is here. Now we know in this case the angle is 90 degrees, but we could take out a smaller piece that would have a smaller angle, for example. Then if we think about, so we have then these two radii, or two arms. So let's say this is the center point here, and then this is radius 1. Okay, and then we have this radius here, radius 2. And the radiuses are going to be exactly the same. So whatever the radius, whatever this value for the radius is, it's going to be the same value for this radius. And then what we have is, we have this piece here. Okay, let's say from here, it's like a way to kind of think about it is, it's like a piece of the circumference. And this piece is what's known as an arc. So it's called an arc, that's what we call it. So if you like, imagine this is point A, and then this is point B. So this length from here to here is what's known as the arc of this sector. So the whole thing here is what's known as a sector. And just the letter that we use to represent the arc is just a small case L. So that just represents this arc here. Now what we need to be able to do is, number one, we need to be able to, for example, calculate the perimeter of a sector. So what does that mean? It means you get this length, you get the length from here to here, and then you get the length from here to here, and you add them all up. The other thing that you need to be able to calculate is, you need to be able to calculate the arc length. So for example, from A to B, you need to be able to calculate that arc length. Now the arc length, in order to be able to calculate the arc length, again you have a formula. So the formula that we have for calculating the arc length, so that's theta, so that's the angle that's in here, divided by 360 degrees. So remember, this theta here is going to be in degrees, it's going to be an angle, whatever the angle is of the arc. And that's going to be multiplied by 2 times pi times r. Now if we remember this piece here, so 2 pi r, that actually tells us the circumference. It calculates the circumference of a circle. So for example, 2 pi r will give you the whole circumference. But all we want to do is, we only want to get the circumference of this piece. So if you like, this piece here of the formula, theta over 360, this is like a fraction, for example. So this, for example, if this is 90 degrees, this is going to be 90 over 360. So that will be, if you like, a fraction of the circumference. And that's really what you're getting. If you think about it, if I want to calculate this piece here, okay, this piece here is just a fraction of the whole circumference of the circle, for example. And that's the way to kind of think about it. So we know this formula, we've looked at it in the last video. And then what we're doing is, in order to get the arc length, you're getting, it's just a fraction of the circumference. And that fraction of the circumference is based on how big the angle is that's in here. So if you like the arc, so this is for getting the arc length. Okay, and that's just represented by an L. So arc length is equal to theta over 360. Theta is the angle that's in here, multiplied by 2 times pi times the radius, and the radius is just the length of one of these arms. So if we look at a question, an example question, so what we have here, so we have a sector here. Okay, so this is our sector, and what we're been asked to do is first calculate the arc length. So the arc length is just going to be this piece here. So the arc length is going to be this bit here. Okay, so this will be your arc length. Okay, which is, we give it a small l. So if we remember, so this is our formula here that we use in order to calculate the arc length. And then the other piece is, so that will give us the arc length. And the other thing we want to do is we want to calculate the perimeter. So basically the perimeter is going to be, you're going to add up this side, and then the arc length. You're going to add up the 3 of them together. Now if we have a look here, so this 21 here is the radius, so r is equal to that. So if this radius is 21, then this radius here is also 21 as well. So this here will be 21 centimeters. And if we think of theta, for example, this symbol here, theta is equal to 60 degrees. So this is theta. So this here is theta here. So the first thing we want to do is we want to get the arc length. So let's work out and see what the arc length. So arc length is going to be equal to theta over 360 multiplied by 2 pi r. Okay, so that's theta. So what we want to do is we want to identify what we have. Okay, so the arc length is the unknown. So the radius r, so r is equal to 21 centimeters. And theta is equal to 60 degrees. So remember, this is like a section of a, it's like taking a section out of a whole circle. So we want to calculate this. So let's see what that looks like. So we take what we have and we plug them into this formula. So again, arc length is going to be equal to theta. So this here is theta, this angle that's in here, which is 60 degrees. So it's going to be 60 over 360. Okay, so 60 degrees over 360 multiplied by 2 multiplied by pi multiplied by the radius. And the radius, as we see here, is 21 centimeters. So this is the radius from here to here. So the radius is equal to 21 centimeters. Okay, so what we want to do then is we want to multiply these out. So the first thing I would do here is I would take this fraction here, which is 60 over 360, and I turn it into a decimal. So basically what you're going to do is you're going to take 60 and you're going to divide it by 360 on your calculator. And then what you can do is you can put the rest then into the calculator and work out what it is. So if we take 60 and divide it by 360, that's roughly equal, it's 0.1666, so we can round it up to 0.17. So it's 0.17. Okay, so all I've done here is I've taken 60 and I've divided it by 360. So I've taken this fraction and I've turned it into a decimal, dividing the top part by the bottom part. So I take this and I multiply it by 2, I multiply it by pi, and I multiply it by 21. So you can take these guys here and just plug them into your calculator. When you multiply it out, it works out at roughly 21.43. So 21.43, and if we just round it up to one decimal place, it's roughly equal to 21 21 centimeters. So that's the arc length. So what do we mean by arc length? We mean the distance from A to B. So for example, the arc length is equal to 21 centimeters. So that's the arc length. So arc length is equal to 21 centimeters. Now what it asks you to do is it asks you to work out the perimeter. So the perimeter is basically you take this guy, the arc length, and this guy here, and you add the three of them up. So you add up this side, the arc length, and then this side here. So what will that look like? So it'll look something like this. So the perimeter, let me just write it over here, and just do it in blue. So perimeter then so the perimeter is equal to, you're just adding up these three sides here. So it's 21 plus the arc length, which we've worked out is 21, plus this side here, which is also 21. And if we add the three of those up, 21 plus 21 plus 21, it's equal to 64 centimeters. So the perimeter is equal to 64 centimeters, and that's the perimeter. That's that. So that is sectors, and basically what we're looking at are the two kind of questions that you could be asked. First question is you're trying to get the arc length. Okay, so you're using this formula here. Theta is the angle that's, let's say, here within the sector, or is the radius from here to here, and then the arc length is this distance from here to here. The other thing then that you could be asked to calculate is the perimeter. So the perimeter is just basically like what we've done here. You take the two radiuses, so these two arms if you like, and the arc length, and you add the three of them together. So these are kind of the type of questions that you need to be able to calculate and work on when we're working with sectors. So if you remember, a sector basically is just like a section of a circle, and the way to kind of think about it is the whole circle, you can break it up by degrees. The whole circle represents 360 degrees. If we broke it up into four pieces like this, when we took out one section, we would essentially be taking out, in this case, 90 degrees. So we can think about it like that. So, and this formula here that represents the arc length, represents how to calculate the arc length. We can see here that this first piece represents a fraction. So whatever fraction you've taken out. So for example, in this one, we've taken out 60 degrees. So it's 60 over 360. And then you're multiplying that by this formula here represents the circumference. But instead of this formula, or this piece here, will give you the whole circumference of the circle. But we're only interested in getting a fraction of the circumference that is related to the arc or the sector that we've taken out. So hopefully that makes sense. And again, it's just very important that you can work through these types of questions. Okay, thank you for listening.